Welcome to qnawire.
This is problem 8 of chapter 23. For this problem, we are given the wavelength lambda equal to 670 nanometers. Now let's go ahead and convert that to meters. And multiplying it by 10, it's -9 meters per 1 nanometer. So 1 nanometer is equal to 10 to the 9 meters. We can go ahead and multiply across. And we have 670 times 10 to the -9 meters for our wavelength. The first part of this question asks, find the frequency for this light as it travels through air, glass, and water. So the frequency is determined by the source, and it's going to be constant throughout those materials. In air, we have the speed of light is going to be equal to lambda times f, which is going to be equal to 3.0 times 10 to the 8 meters per second. Here we're going to solve for f by dividing both sides by lambda. So we have f is going to be equal to c over lambda. Let's go ahead and plug in the values. For c, we have this in meters per second. And for lambda, we have this in meters, so that's why we converted to meters at the outset, so that m cancels out with m, and all that's left is inverse seconds, which is hertz. This comes out to be 4.5 times 10 to the 14th hertz. Since frequency is determined by the source, that frequency is going to be equal to the frequency of that light as it travels through air, as it travels through glass, and as it travels through water. It's that same quantity. What changes for the light as it travels through the different materials is the wavelength. To find the wavelength as the light travels through, say, the glass, we're going to need the refractive index of the glass. And that's given as 1.60. So this is defined to be the speed of light over the velocity of light in that medium, which is v of glass. Let's go ahead and solve for v glass. We multiply both sides of the expression by v glass. We get v glass n glass is equal to c. Now let's go ahead and divide both sides by n. We get v glass is equal to c over n glass. But velocity is just lambda glass times frequency glass. But frequency glass is just f, so we'll just leave it without the subscript here. Okay, here we can solve for lambda glass. As being c over f n glass. Now let's go ahead and plug in all the values. C is going to be speed of light. F is the quantity we just calculated. And n glass is 1.60. Hertz is inverse seconds cancels with inverse seconds, and what we're left with is meters. So when we plug this in, we get 4.19 times 10 to the -7 meters. So let's go ahead and convert this to nanometers. 10 to the -9 meters is equal to 1 nanometer. So when we simplify this, we get lambda glass is going to be equal to 419 nanometers. Okay, so this is for glass. We're going to repeat this calculation for water. So N of water is going to follow the same pattern. Let's go ahead and do it right here on the side. This is going to be equal to 1.33, which is going to be equal to the speed of light in vacuum over the speed of light in water. We repeat the procedure. We're going to solve for the velocity of light in water. So this is going to be the same algebra as the one for the glass. We're going to multiply both sides here and then divide by N water. So it's going to be C over N water. And this is going to be equal to lambda water, the wavelength in the water, times the frequency in the water, which is just F. Okay, here let's go ahead and solve for lambda water. We divide both sides by F. Now we plug in the specific values. So for the speed of light, that's unchanged. Nothing changes but the refractive index of water here. So I'll just go ahead and copy this from before and just change this denominator. So the denominator here is going to be 1.33, and when we solve for this, it goes out to 5.04 times 10 to the negative 7 meters, which is 504 nanometers. So the conversion follows what we did here in this problem. When it's times 10 to the negative 7, we could go ahead and multiply by this conversion factor, and it shifts the decimal place to the right. Okay, so this concludes problem number 8.